We've landed robots on Mars, we've mapped the entire surface of the moon. We look up at the stars and feel like we've conquered so many frontiers. But what if I told you the greatest unknown isn't out there in space, but right here on our own planet? Okay, let's dive into this.
I mean, think about that for a second. It's kind of wild, right? We have these incredibly detailed maps of the moon, which is 250,000 miles away. Yet the vast majority of our own ocean floor is still a complete mystery. We literally know more about the surface of Mars than we do about what's sitting at the bottom of the Pacific.
So you gotta ask, why? Why is it so much harder to explore our own backyard than it is to explore deep space? Well, a big part of it was the Cold War, right? That fueled a space race that pushed technology to look up. But it also turns out that going down is, in so many ways, way more difficult than going up. The journey into the deep is blocked by 3 immense barriers. So, let's start our descent and tackle the first one. The first and honestly the most powerful challenge we face is this constant, unforgiving, and absolutely immense force, the crushing weight of the water itself. Okay, so picture this. Every single meter you descend, the weight of the entire column of water above you is pressing in on you from every direction. This isn't like the air pressure we're used to. This is a physical, relentless force that just gets stronger and stronger the deeper you go. And to put that in perspective, at just 1 kilometer deep, which, by the way, is barely scratching the surface of the deep ocean, the pressure is already strong enough to implode a standard military submarine. We're talking about an environment that just wants to squash everything flat. And imagine that kind of force in the deepest parts of the ocean, like the Mariana Trench. It's a weight so extreme, it's almost impossible to really wrap your head around. So any vehicle we send down there, whether it's manned or robotic, has to be built like an armored fortress just to survive, which makes exploring incredibly difficult and expensive. But okay, let's say you engineer a vehicle that can somehow withstand that pressure. You solve that one massive problem, but you immediately face another, more primal one. You can't see a thing. And that brings us to our second great barrier. The part of the ocean we're all familiar with, that sunlit zone with coral reefs and most of the fish we know, is an incredibly thin layer right at the very top. Once you get past about 200 meters, the sunlight just fades away completely. And I'm not talking about a dim, twilight kind of world. I mean absolute, total, permanent darkness. It's a blackness more complete than the darkest night you've ever experienced on land. A world that has never, not once, been touched by a single ray of sunlight. Now, this creates a huge practical problem for us. Any camera, any vehicle is totally blind without its own light source. But water is really good at absorbing light, so even the most powerful deep-sea lights can only illuminate a few meters ahead. It makes exploration painstakingly slow. It's like trying to map an entire continent using just a tiny flashlight. So we've got crushing pressure and we've got absolute darkness. But surely, with all our modern innovation, we have the tech to overcome this stuff, right? Well, that's what brings us to our third and final barrier. Our technology is still playing catch-up. And here is the core of the problem. We can communicate almost instantly with a rover on Mars using radio waves. They just zip through the vacuum of space, no problem. But those exact same signals get absorbed almost immediately in salt water. So what does that mean? It means we can't just remotely pilot a deep-sea drone with a joystick in real time like it's a video game. So even our best robotic explorers are seriously held back. The immense pressure wears them down. Their batteries limit how long the mission can even last, and communication has to rely on these slow, low-bandwidth acoustic modems, basically sending data through sound waves. It's like trying to stream a 4K movie over an old dial-up connection from the 90s. It just doesn't work well. So when you combine all of those challenges, the pressure, the darkness, the tech issues, you arrive at this one single, staggering number. 5%. That's it. After centuries of sailing the seas and decades of modern science, we have mapped just a tiny fraction of our own planet's foundation in any real detail. So, what does this all mean? It means that the biggest wilderness, the largest habitat, and probably the greatest source of mystery on our planet is still just waiting to be truly discovered. So to recap, it all really comes down to this trio of obstacles, right? First, the incredible force of extreme pressure.
Second, the fundamental challenge of trying to operate in total darkness. And third, the current limits of our communication and power technology. You put those three together, and they've kept the deep ocean one of the most inaccessible places known to humanity. But here's the really thrilling part. This mystery isn't just an empty void. It's a space that's filled with potential. It's a place that could be hiding bizarre new forms of life that are perfectly adapted to these extreme conditions, undiscovered underwater volcanoes, and maybe, just maybe, the answers to some really fundamental questions about how life began on Earth.
So, as our technology slowly but surely gets better at overcoming these barriers, we're really standing on the brink of a brand new age of discovery right here on our own planet. It just makes you wonder, what amazing, strange, and world-changing secrets are waiting for us down there in the dark?